So welcome. We want to look on hyperbolic functions. So let us look at the definition. These are functions which are associated with the geometry of a conic section called hyperbola. So now let us look on the different ways how we express these hyperbolic functions. So hyperbolic sine of x is expressed in this form. Number 2, hyperbolic cosine of x is expressed in this form. Number 3, hyperbolic tangent of x is expressed as a ratio of sine hyperbolic of x and cosine hyperbolic of x. So we express this as number 4, hyperbolic cosecant of x is expressed as the reciprocal of the hyperbolic sine of x, and so is given in this form. The hyperbolic secant of x is expressed as the reciprocal of the hyperbolic cosine of x, so it is expressed in this form. Hyperbolic cotangent of x is expressed as the reciprocal of the hyperbolic tangent of x, so it is expressed in this form. Well, we now want to look on the properties of hyperbolic functions. So the first property is that hyperbolic sine of 0 is 0. Hyperbolic cosine of 0 is 1. Hyperbolic sine of negative x equals to the negative hyperbolic sine of x. That is the same case for hyperbolic tangent, hyperbolic cosecant, and hyperbolic cotangent. So we classify these functions as odd functions because they are defined by if we have the function of a negative variable, it becomes the negative function of that variable. This is what defines the odd functions. So other properties, on the other hand, hyperbolic cosine of negative x equals to the hyperbolic cosine of x. The same case for hyperbolic secant. So this group of functions, we classify them as even functions because they are defined as that if you input the negative variable, it is the same case for the positive variable. So those are the even functions. Right, so we want to move to the next part, and that is the hyperbolic identities. So hyperbolic identities are like formulas that help us in solving hyperbolic functions. So we want to look on these identities one by one. The first identity is, so we want to prove it. So let us remind of ourselves of this identity of quadratic expressions. So if we expand this left side according to this identity. We will have this one. So by expressing these functions in this form, we write as so by opening these brackets and solving, we have and so this one becomes 1. So this has become equal to the value in the right hand side. So that is our first identity. The second identity is that 1 minus the hyperbolic tangent square root of x equals to the square of the hyperbolic secant of x. So we want to prove so we want to expand the left hand side. So we would have this is also the same as so solving it comes so from our first identity is that cos hyperbolic squared x minus sin hyperbolic squared x equals to 1. So this is our numerator, then equals to 1. So this one becomes and this is like saying so that's what is in the right hand side. So that's our second identity. Our third identity, so we want to prove it by simplifying this expression. We have so by simplifying it, we have from our first identity, this our numerator equals to 1. So it becomes so another identity here. So prove, first of all, let us express the right hand side in its correct form. So this now is the hyperbolic cosine of 2x is now written as right. So now let us deal with the left hand side. So expressing hyperbolic sine squared of x in its form, we have so expanding that bracket becomes so now 2 minus 2 becomes 0, and so we have find this one, and so this is what we add in the right hand side, right? So you can see that those identities are just very clear and straightforward. So we want to look at other identities just in summary. This is the identity we have just proved. So but it is also equal to and also equal to this one. So another one, so these are our hyperbolic identities, including so want to move to the next part, that is on solving hyperbolic functions. So the methods used in solving the hyperbolic functions, the first one is use of tables. This one is when values of various functions are given, and referring to these tables you can be able to solve others. This method is not commonly used. Another method is use of graphs. The values can also be found graphically. That method, the use of a calculator, is also another method that is commonly used. Here we want to look on examples of solving hyperbolic functions by the use of a calculator. Here you just key in your values in your calculator, like so you have your value, then you write. So for example, you will be asked to evaluate a hyperbolic tangent of 0.38. So here you also use your calculator, but first you express the cotangent hyperbolic as the reciprocal of the hyperbolic tangent of 0.38. So this is so that is so that is it. So you may also be asked to solve the equation of this form. So let's see how to handle it. The first step is to express these hyperbolic expressions in their correct form. We write, so we open the brackets, so putting the right terms together, this and this, and this one and that one. So we write right. So here we divide every term by e to the power of negative x. So we have, so we arrange the equation right. So by the use of the quadratic formula, we find the value of e to the power of x as, so these are our values. But now, because this one will not give real answers, so we ignore it. So we find the value of x from this equation. So by taking the natural logarithms for both sides, we have, so we find that one. So you are given this equation and you are asked to find a and b. So what to do, you express the left hand side and also the right hand side. But the left hand side is fully simplified, so we express these hyperbolic expressions in their correct form. So now we open the brackets, we put the right terms together, this and that one, this one and that one. So we equate this value to the value in the left hand side. So we have, so now we equate the coefficients, this and this one, this one and this one. So we have so therefore, so this is, so these are the value of A and B, right? Yeah, the fourth method of solving hyperbolic functions is the series method. So by definition, e raised to the power of x is expressed in this form. And so therefore, when we have e on add x, we express it as, so if we have hyperbolic sign of x, for example, we can express it as, so this is the simplest form of sine hyperbolic of x. Also, for the hyperbolic cosine of x, we have, so this is the final expression of hyperbolic cosine of x. Let us now look at this example. You are asked to determine the power series solution for these expressions as far as the term in theta raised to the power of 5. So let us see the, so the first thing, you express these expressions in their correct form. So this is how we express this expression. So by opening the brackets and solving, we have this one. And also now for hyperbolic sine of 2 theta, we have, so by simplifying this series, we obtain, so now back to our equation, we have, so this is the final expression, that is the power series solution. So those are the methods of solving hyperbolic functions. Yeah, subscribe to our channel and always be ready to watch for more videos. Thank you for watching.